Here's an old one that is increasingly relevant today, a 1977 paper entitled Circular Polarized Luminescence Spectroscopy by Frederick Richardson and James Reel, one might say the founders, the developers of this important technique, which is really increasing use in the last several years. And I'm just going to cover, I think it'll be relevant for us just to look at the introduction to this paper from, again, 1977. Chiral optical methods have been used for many years to probe the stereochemical and electrical structural features of molecular systems. Optical rotation, optical rotationary dispersion, ORD, and circular dichroism, CD, are extremely sensitive probes of molecular stereochemistry in naturally occurring active chiral systems, and the observables associated with each of these phenomena may be related directly to parameters characteristic of specific electronic structural details. In most cases, the structural information obtainable by these three chirooptical techniques concerns molecular conformations or configurational features characteristic of thermally equilibrated, relaxed electronic ground states. In principle, one may also acquire structural information about electronic excited states from CD spectra by detailed analysis of band shapes and vibrational structuring within CD bands, but even when sufficiently resolved CD spectra are available, such analyses depend upon rather uncertain theoretical models of spectroscopic vibrational transitions. In practice, then, optical rotation, ORD, and CD, both electronic and vibrational, must be considered as probes of molecular electronic ground state structures. Recently, 1977, considerable interest has developed in using the emission analog of CD to investigate the structural features of the emitting states in chiral luminescent molecular systems. This phenomenon has been variously referred to as circularly polarized emission, CPE, and circularly polarized luminescence, CPL. We shall adopt the latter designation, CPL, in the present review, although it should be understood that they have identical meanings. Just as CD refers to the differential absorption of left and right circularly polarized light by chiral systems, CPL refers to the differential spontaneous emission of left and right circularly polarized light by chiral luminescent systems. However, whereas the CD observables reflect the chirality of molecular ground states, the CPL observables reflect the chirality of molecular emitting states. CPL then provides a probe of configurational and conformational structure in the emitting or luminescent states of molecular systems. With regard to molecular structural parameters, the underlying physical principles of CD and CPL are quite similar, and the experimental methods required to measure these two phenomena make similar demands upon instrumentation technology. However, whereas CD has been used extensively over the past 15 years in molecular structure studies, development of CPL spectroscopy has occurred mostly over the past 5 years. Now, this paper has been cited by 424 publications so far, 100 of which I hold in my hand, and they're almost all, in the last 5 years or so. 50% are literally in the last 5 years. So just a few of the newer papers: cholesteric liquid crystal polymer networks doped with axially chiral fluorescent dye, CPL, and anti-counterfeiting applications. Intense circularly polarized luminescence induced by chiral supermolecular assembly, the importance of intermolecular electronic coupling. Circularly polarized light emission from encapsulated aggregation-induced emission achiral lumigen within the supermolecular helical nanofilament network, and on the list goes. Aggregation-induced emission, together we shine, united we soar. Interesting title. Circularly polarized luminescence in chiral molecules and supermolecular assemblies. That's a pretty generic title. That actually came out in Journal of Physical Chemistry Letters in 2015. So if you're interested in circularly polarized luminescence, which obviously you should be if you are working with chiral samples, and just to quote someone that I heard at a chirality conference, chirality is ubiquitous, and your samples emit, then let's talk CPL one day. I look forward to it.